Everyone, it's time that we move on to our applications of differential equations. And the first application we're going to look at is family of solution. So what is family of solution? Let's start with a very simple example. dy dx equals to x. So basically you find the general solution, you get y equals to, well, increase the power by 1, then divide by the new power to get x squared over 2, and not forgetting your arbitrary constant plus c. So what happens here is that you notice that there's this arbitrary constant c, right? And you can take any real values, right? So basically there are a lot of possible solutions. Let's say we have c equals to 0, we'll get a quadratic graph passing through the origin. If we let's say get c equals to 1, it's just 1 unit, it's a translation of 1 unit at the positive y direction. If we let c equals to minus 1, it's a positive, it's a translation but descendant y, negative y direction. So as you can see, right, there are multiple, actually infinite possible solutions, right? And the graph would change, okay? Sometimes the different constants could cause a very basic change, like in this case it's just a translation. Sometimes it changes the graph quite drastically. So the idea is that the family of solution basically is what we call by a general solution. It has multiple infinite number of solutions that are possible, just that sometimes they only ask you to sketch, like let's say particular values like c equals 0, c equals 1, c equals minus 1. You're not required to show every possible solutions. That will be impossible anyways. Now we move on to what we call by a particular solution. So by the name, right, it's just basically a more specific solution. It's actually just one particular solution, right? So let's say we have the same example, okay? dy dx equals to x, right? We seen from earlier, you solve it, it's just same thing on y equals to x squared over 2 plus c, all right? Now though, the question gives you more information. They tell you that the original graph passes through the point, maybe let's say 5, 20, right? So x equals to 5, y equals to 20. So with this two information, you're able to find the value of c, right? Because you can just sub in y equals to 20 and x equals to 5 to give you 20 equals to 25 over 2 plus c. C is therefore just 20 minus 25 over 2. So basically 40 over 2 minus 25 over 2 to give you 15 over 2, which is also 7.5. All right. So now you actually found a particular solution, right? Because you're now solved for c. So it's no longer an arbitrary constant. You actually solve exactly for c, and therefore your curve is exactly y equals to x squared over 2 plus 7.5 or 15 over 2. And you obtain exactly one solution that has no other variables or no other constant, no other varying constants, right? No arbitrary constant c or d or f. So if you have to sketch this particular solution, you just need to only sketch one graph because only one solution. It's just x over 2 plus 15 over 2, where the graph passes through 0 and 15 over 2. And yeah, so that's about it for family of solution and particular solution.